Today I want to introduce you to a new MLX80339 code-free product for brushless DC fan drivers. Typically, controlling a three-phase BLDC motor takes some development time, tuning and testing time, and validation time. We want to cut this time by providing you pre-validated logic with all motor control inside. And I will show you how easy it is to set up your product with our start-to-run tooling and our MLX80339 development kit with the Melexis Compact Master. The MCM board contains two chips. One is a QFN24 package, which we will use to characterize the motor in the start-to-run tool, and an SO8 package, which we will use later with the configuration coming from start-to-run to run the motor with our offline GUI tool. Using the kit is very easy. You only need our development board, the MCM, a standard USB-C cable, a very simple 12-volt or 24-volt supply, whatever your application needs, and of course, your motor. Connecting everything together is as well extremely easy. Connect the supply, connect the USB-C cable, both to the board and your PC, and then connect, of course, your motor. We're now ready to start characterizing and tuning the motors. Once everything is connected together, we can go to the Start-to-Run website and create our motors. We just fill in the name of the motor you want to test, give the maximum phase current you want to use, and that's it. Now we can characterize the machine, selecting our Melexis Compact Master board and starting the characterization. This will take a few minutes, in which the tool will first characterize the electrical parameters of the machine, like inductance, resistance, back EMF, and so on. And in some second steps, we'll try to estimate the mechanical parts of the system, like the load and the inertia. This will take a few steps, but in a few minutes, everything should be ready. Once the characterization phase is done, you will be presented with the measurement results, and we can now request some auto-tuning, which in the background on our servers will generate all the optimal gains for the controllers for the motor control loops and tune the starter behavior of the motor to provide a smooth experience. Now the auto-tuning is done and we can test the behavior on the target itself. Again, select the Melexis Compact Master and connect to the device. Now we are connected, we can verify the tuning and the characterization was successful by trying to start the motor. And as you can see, the motor responds very well to a speed target. What you also can do is tune the configuration a bit in this configuration tab. For example, let's say we want a ramp rate on the speed request. Let's fill something in. We write it to the chip's EEPROM and we try again. And as you can see, the motor now responds a lot slower to a speed request and applying the ramp rate we've set earlier. Now we can continue and tune and configure even further in our offline GUI tool. For this, we will download the EEPROM file we have generated with Start-to-Run to our PC, and we can now connect to the local GUI. To do this on the MCM, we switch the jumpers to the code-free chip, and also, of course, switch the motor connections around to the correct side of the board. Then in the GUI tool, we will connect to the MCM and load the EEPROM we've generated earlier with start to run. And as you can see in the top, all the information from start to run is now loaded in our local tool. We will connect to the MCM again and verify that all the motor configuration that was generated and is now loaded in the actual code-free chip is behaving exactly the same as in the online tool. And as you can see, of course, the motor responds exactly the same. Let's try again setting an acceleration limit the same as we did in the start to run tool. We write the EEPROM again to the chip, and we can verify the motor is now starting up slower and applying the acceleration limit we set earlier. Some more things you can do in the GUI, which you could also do in start run, of course, is setting the communication type you want. We have legacy PWM for easy drop-in replacement, fan control, or more advanced digital communications like I2C and UART. You can also adapt some motor parameters like max speeds, max currents, and of course the acceleration and deceleration limits I showed earlier, and set some diagnostic limits like the over/under voltage and over temperatures. So, as you can see, it is very easy to start running a motor with our code-free chip and our start to run tool. In just a few minutes, we have characterized and tuned and tested the chip without writing a single line of code. It's time to start spinning and stop coding. For more information, visit our website.